Okay, shall I? Everyone return the heading. So wedge constraint is the last topic of your constraint motion, and similarly you are also finding one constraint here. Okay, how you have found one constraint in pulley wedge constraint and what only pulley constraint, or yes or no? And similarly over here also there is one constraint. And what is that constraint? Let me tell you first. It says that velocity of the bodies, velocities of the body perpendicular to the contact surface. Perpendicular to what? The contact surface must and should be same. I got my point? Let us try to understand this by example. Come on. Consider here is one surface, and on this surface there are two masses has been placed, 2, 3, 5, 10, whatever you want to take the values you can. Okay, so this is your body A, and consider just beside and it is in contact with A, here is your B. Two bodies A and B are being placed. Okay, so can I say that this is the contact surface? This is your contact surface now. Yes or no? And first, the second thing what we need to know is these bodies must and should be rigid bodies. That means they are the atoms or the points where you are marking, they are not going to change their position at all. Body A position, for example, this is your point A and this is your point B. They are not going to change. Either it is going with whatever the velocity, let's say in this direction, body A is going with velocity V1. I got my point? That means, can I say this point is also going with V1 velocity? Obviously. Now, we know that obviously this B will be going in this direction, and let's say it is going with V2 velocity. Two bodies are in contact. Here is the contact surface, and we have what we have done. We have marked 2 points which is perpendicular to the contact surface. Okay, if I join these two lines or the points, let's say this is your point 1 and this is your point 2. Okay, now tell me, point 1 will be going with same velocities, that is what V1, or yes or no? Point 2 will be going with velocity V2, or yes or no? Okay, according to the constraint, wedge constraint, it says that velocity along the along this line, or can I say perpendicular to the contact surface? Can I? Along this line it should be equal, and where we are marking this line? Perpendicular to the contact surface. I got my point. That means this point is going with V1 and this point is going with V2. Both are going in the same direction. That means V1 is equals to V2. Okay, let us move ahead. Okay, now? Okay, now consider here are the two bodies like this. Okay, here is one sphere which is being placed, and one more sphere is in contact with here like this. Where is the contact surface? Can I say in between these two, can I draw a tangent, common tangent? Yes. So common tangent between the body A and body B is acting as your contact surface. So this is the contact surface now. Okay, consider this is your body A and this is your body B. I got my point? Okay. Now let's say V1, this is the going with in the downward direction. Obviously B will be going in this direction by V2 velocity. Are yes or no? Okay. Now if V1 is going in this direction and V2 is going in this direction, all we need to do what? We have to mark 2 points which is perpendicular to this contact surface. So this is your contact surface and I want 2 points. That means let's say over here is 1 point and over here is 1 point. I am drawing 2 points. That this is your P1 and this is your point number 2. I got my point. This should be perpendicular to each other. Yes. Okay. Now tell me, this one is point 1 is going in this direction or in the downward direction? Downward direction. So this one is going in this direction like this, and it is going with V1 velocity, and point number 2 is going in this direction by V2 velocity. I got my point. Let's say this angle is given θ1. I got my point. And this angle it is making, let's say, θ2. Where it is making this angle? Let's say over here it is making θ2. I got my point. Okay. Now, if this one is your V1, then what will be the velocity here? Then can I say that V1 cos θ1? Yes or no? So point number 1, along the perpendicular, this is the line, along the line which is perpendicular to what? The contact surface. Then can I say that V1 of cos theta 1 should be equal to, if this is your V2, then over here the velocity will be V2 cos theta 2. I got my point. Let's say this is V2 cos theta 2 and both should be equal. I got my point. So always remember that either the component of the velocity where perpendicular to the contact surface. If I join a line between two bodies which are making perpendicular to the contact surface, along that line velocities must and should be equal, or over here a simple illustration. Got my point? Right on. Okay, shall I with example number 1? I will do the one, then you have to try the next. Okay, given that here is a surface, and on this surface two bodies are being placed like this. This is your body 1. Okay, this is your A, and here is your B. Two bodies, this is your P. Okay, given that A is going in this direction by V1 velocity, if A is going in this direction, definitely B will be going in that direction now. So let's say this one is going with V2 velocity. Okay, they will also provide you this angle. At what angle both are in contact with each other? Let's say this is theta or 37? 37. Okay, so this one is making an angle 37 degree. Okay, how to do the answer? Let us try to understand this. First, draw the contact surface. Here is the contact surface and it is making an angle how much? 37 degrees. Yes or no? All we need to substitute what 2 points over on the bodies. So let's say this is your point number 1 and this is your point number 2. All we need to join this perpendicularly. Yes. So perpendicular to the contact surface is being done. So can I say that this is your point 1? Let's say this is your point 1. And let's say this is your point 2 here, somewhere here, let's say P1 and P2. Okay, now velocities along or perpendicular? Perpendicular. Velocities perpendicular to the contact surface must and should be same. Where P1 is going, that means where body A1 is going, A is going in the downward direction. Let's say this one is going in this direction by what velocity? V1 velocity. Yes or no? And B is going in which direction? B is going in this direction by V2 velocity. Yes or no? Yes? Okay. Now all we need to do what? Simple calculation. So we need to find this angle. What will be this angle? And if I say what will be this angle? Okay. Now if this is 37, obviously this one 53, this one is 90. This becomes again 37 degree. Can I write like this? Okay, ले ये 53 हो जाएगा ना बेटा, perpendicular है. Okay, okay. Now, so this one is V1 and obviously this becomes what? V1 cos of 37 degree. One velocity of P1 is done. Okay, now P2. This one is 90 degree. Yes or no? If this is 37, this one is 90. Obviously, this becomes what? 53. If this one is 53, this one also becomes 53 degree. Why? Because vertically opposite angle. If that velocity is V2, obviously in this direction, that is what? V2 cos of 53. Yes or no? Then can I say that V1 cos of 37 should be equal to V2 cos of 53 degrees. Okay, substituting the value, that answer is done. So cos 53, 4 upon 5, which is equals to V2 sin 53, that is of 3 upon 5. Can I cancel this 5 and 5? Then V1 is equals to 3 upon 4 V2. Okay, all there will be a slight substitution of angles only. Okay, no? Okay, shall I example number 2? You have to try this now. Okay, and consider a triangular wedge is being placed here, making an angle again 37 degrees, and an object is going in this downward direction like this. Okay, this object is going in the downward direction by v1 velocity. This is your A, this is your B. Angle is given. First thing, where do B goes? In that direction or this direction? Yes, very good. So B will be going in this direction by v2 velocity. Again, question is same. Find the relation between v1 and v2. Everything is given. Come on. Okay, how many of you got the answers? Let me check your answers. Are they correct or not? Let me draw the first what? Contact surface. So this is your contact surface making an angle how much? 37 degree. So this is your 37 degree, marking what? 2 points on the block A and block B. Okay. Then can I say that, let's say this is the point and this is your P1, this is your P2, and P2 is going in this direction by V2 velocity, and V1 is going, that is what P1 is going in this direction by V1 velocity. Are yes or no? Okay. Joining these, you will get the what? Values of what? Triangles na. Are yes or no? Definitely this line will be passing from the center. इसको ऐसा ले लो थोड़ा सा. Okay, now you can see the angles clearly. Now, if this one is 37 degree, obviously this becomes 37 degree. Are yes or no? Okay, if this one is 37, this becomes what? 53. If this one is 53, this one is 90, obviously this becomes what? Let me write the values also. This is 53, this is your 37, obviously this becomes what? 37 degree. Yes or no? So P1 is going, this point P1 is going in the downward direction, then what will be the velocity this along this line? That is what? V1 cos of 37 degree. Are yes or no? We need to find these velocities na beta, along this one. Okay. Similarly, calculating this, now you need to find this angle. Okay, so you need to calculate this angle. Obviously, in this triangle, this one is 90 degree, this one is 37, this one becomes what? 53. If this one is 53, this also becomes what? 53. Are yes or no? Then if over here is V2, then this becomes what? V2 cos of 53 degree. That means V1 cos of 37. V1 cos of 37, which is equals to V2 cos of 53, and substituting the values again, this is your 4 by 5, which is equals to V2 3 by 5, 5 get cancelled, again V1 is equals to 3 upon 4 V2. Same answer आया. कितनों का आया था? Very good. Those who have got this answer, that is correct. Okay. Okay. One more example. Let's say, let us move to 3 bodies. Okay. Now consider, given that 3 bodies are being placed on this surface. Let's say this is your body 1, this is your body 2, and this is your body 3, like this. अच्छे से बना लो by diagrams. Okay. 3 bodies are in contact with each other. All are similar. Same radius, same mass, everything is same. Okay. And all you need to find the relation between V1, V2 or V3. Let's say this one is going in the downward direction. So this one is your center, this one is your center, this one is also center. This one is going in this direction. This is your A. This is A going with V1. This is your B. This is your C. Okay. Can I say that velocity of B and velocity of C will be equal? Again, I am telling you, all are same. Okay. Radius, mass, everything is same. Either consider these are the pipes like this, your wish. Okay, or either consider this sphere. The answer values will be same. Okay. Now, how to do the answer? If this one is going in the downward direction, first see, you will be finding, if you join, this is your contact surface, na beta. This is your first contact surface here. Are yes or no? This is your second contact surface here, and this is your third contact surface here. Okay, take any two, complete the answer. The velocity of this body and the velocity of this body will be same. Okay, come on, try this. Okay, shall I now? हो गया, नया आ रहा तुमको, छोड़ दो. Okay, So this is your contact surface. Then can I say joining this and this? Can I join this? Or yes or no? If this is the contact surface, I can also join these two centers. Similarly, if I join these two, I will be getting a triangle, and that triangle should be equilateral triangle. Look, all sides are equal now. This radius is same, this radius is same, these two radiuses are same, these two radiuses are same. Obviously, I will be getting a triangle like this, and this triangle will be a equilateral triangle. All angles should be 60 degree. Are yes or no? Yes? Okay. Now, this point number 1, let's say this is your point number 1, this is your point number 2, this is your point number 3. Point number 2 and point number 3, again and again I am saying why they are going with same speed. You will understand now. Okay. Now, velocities along what? Perpendicular to the contact surface should be equal. Then can I say that V1 is going in this direction? This is the direction of V1. Yes. If it is passing in the downward direction, then can I say this becomes 30 degree and this also becomes 30 degree? Obviously, it is passing through the center. Yes. So can I say in this direction? That means in this direction, can I say V1 cos of 37? Yes. Okay. Where is V2 going? P2 is going in this direction. P2 is going in this direction by V2 velocity, and P3 is going in this direction by V3 velocity, and V1 is obviously given. It is going in this direction V1. Are yes or no? Okay. If this one is going in this direction, then this is your P2, and P2 is going in which direction? In this direction. Are yes or no? But velocity should be along this line. Along this line. Yes or no? If this one is 60, obviously this becomes what? 60. Similarly, come over here. Why I said? Now, this one will be the V3. This one is V3 and this one will be V3 cos of 60 degree. Similarly, over here, this is what? V2. V2 cos of 60 degree. What is the relation between V1 and V2? Same. Similarly, V1 and V3 will be equal. Okay. Now, V1 cos of 37 degree, which should be equal to V2 cos of 60 degree. Sorry, 30 ना. Sorry. लिखते वक्त नहीं बोलते रहे. Okay. So V1 cos of 30 degree should be equal to V2 cos of 60 degree. Substituting the value, V1 cos 60 cos 60 degree is what? Root 3 by 2, which is equals to V2 cos of 1 by 2. To get cancelled, again, can I say that V1 is nothing but V2 upon root 3. Okay. You can find n number of problems in various books. The concept remains same. Always draw the contact surface, then take 2 points which should be perpendicular to the contact surface. Velocities along the contact surface, perpendicular to the contact surface should be same. That's it. Simple concept. I got my point. Okay, right on.